Multiple inheritance in Python. Let's talk about multiple inheritance, its syntax, the MRO, and some complications with multiple inheritance. Multiple inheritance is when a class inherits from multiple base classes. Class brunch inherits from class breakfast and class lunch. How do we implement this in Python? We define the base class as we would, and when defining the child class, we put the names of the base classes in parentheses to it. Brunch inherits from breakfast and lunch. Now, if we try to access an attribute or a method in brunch, but it doesn't have it, does the interpreter look for it in breakfast first or in lunch? For situations like this, it has something called the method resolution order, the MRO. It first searches in the current class. If not there, it searches in the parent classes. Such an order of search goes left to right in a depth-first fashion. This is our code. These are the classes. It first searches in brunch, then in breakfast, and then in lunch. And if still to be found, it looks for it in the object class. In Python, every class is a subclass of the object class. So here, it searches in brunch, then in breakfast, then in lunch, and then in object. We call it the order of linearization of the brunch class, and the set of rules that are applied are termed the method resolution order, or the MRO. This uses the C3 linearization algorithm. If you would like to ask Python for a class's MRO, the MRO attribute will give it to you as a tuple, and the MRO function will give you a list instead. We learn better when we learn from multiple examples to make sense of. So let's take another example. Classes red, yellow, and blue inherit from nobody. Orange inherits from red and yellow. Green inherits from yellow and blue. Slate gray inherits from green, orange, and blue. What order does it follow? What is the MRO for the slate gray class? First, the class itself, then green and orange, red and yellow, then blue, finally object. Let's see how we got to this order. First, the MRO of red is red, that of yellow is yellow, and that of blue is blue. For orange, it is orange plus merge of linearization of red, linearization of yellow, and the list red and yellow. The linearization of parents and the list of parents. This is the list orange, red, and yellow. Similarly for green, it is green plus merge of linearization of yellow, linearization of blue, and the list yellow and blue. This is the list green, yellow, and blue. And now the MRO for slate gray. This is slate gray plus merge of the linearizations of green, orange, and blue, and the list green, orange, and blue. This is slate gray plus merge of these four lists. Green is a good head because it does not appear anywhere but in the head in the other lists. So we'll take this over to the list holding slate gray, and we'll remove this from all other lists. We still have four lists to merge. Now yellow is not a good head because it appears at the end in the second list. Orange? Yes, it's a good head. Let's take it over. These are the four lists that remain now. Yellow is not a good head because it appears second in the second list. But red is a good head. Now, yellow is a good head. Let's take it over. And now, all that's left is blue, and it is a good head too. What we get now is the MRO for slate gray. Slate gray, green, orange, red, yellow, and blue. Let's take one more. B inherits from A, D inherits from B, C, and A. What's the MRO for D? D, B, C, A, an object. And this one? B inherits from A and D from B and C. D, then B, A, then C, and then object. Let's figure out these two as well. Linearization of A is A. For C, it's C. For B, it's B plus merge of linearization of A and the list A. This is the list B and A. For D, it is the list D plus merge of the linearizations of B, C, and A and the list B, C, and A. This is D plus merge of these four lists. B is a good head. Let's take it. A is not a good head as it appears at the end of the last list. But C is a good head. Now A is a good head. So the MRO is D, B, C, A. And for the second situation, all other than D is the same. For D, this is the linearization. This is equal to the list D plus merge of these three lists. B is a good head. Let's take it. And now A is a good head. And now C is a good head. So the MRO is D, B, A, C. But what happens when a class inherits from multiple base classes and they all have a common attribute? Whose value does the child take? That is the question. Classes Physics, Chemistry, and Maths have IDs 1, 2, and 3. Class Student inherits from these three. What ID does Student have? 1 from Physics. And if we mentioned Chemistry first in the names of parent classes, it would be 2. Here ID is an attribute, but the same is true for methods as well. See this one, subject has ID 1. Biology and chemistry inherit from this and have IDs 2 and 3 respectively. Biochemistry inherits from biology and chemistry. What is the ID for the class biochemistry? Okay, so this is what's happening. And the ID is 2 because of biology. Here, classes X and Y inherit from class object. A and B inherit from X and Y and X. If we now define a class C that inherits from A and then from B, this raises a type error stating it cannot create a consistent MRO for this situation. This is because A inherits from X, then from Y, but B inherits from Y, then from X. This was multiple inheritance in Python. Next, we'll learn about operator overloading.